Our last idea today then is the idea of acceleration. So acceleration is going to measure your change in velocity over time. There are a few different ways that you can change your velocity. One way you can change your velocity is you can speed up. The opposite of that would be to slow down. But then you can also change your velocity by changing your direction. Since velocity measures both speed and direction, if you change your direction, you're going to change your velocity. Acceleration can be a value that is a positive number or a negative number, and that positive or number are going to tell you the way the acceleration is changing. So if you speed up, that is going to be a positive change in acceleration. Your acceleration will increase. If you are slowing down, it's still acceleration, but we're just going to use a negative number. You're going to get a negative acceleration since your acceleration is decreasing. And then changing your direction, because you could assign direction to velocity, and you could say that this direction is positive and this direction is negative, changing your direction could make your value of acceleration either positive or negative, depending on the change in motion. When we solve for acceleration, we are going to use the formula acceleration is equal to the change in velocity over time. This little triangle here is a symbol. It's delta. So delta is a Greek letter. And whenever you see delta in a scientific formula or a math formula, it means the change in. So the top of our formula here is just how did velocity change over the time it took to change it. Delta V is equal to the difference in your velocity, your final velocity, minus your initial velocity. So you're going to find delta V by taking the velocity you ended with minus the velocity you started with. When you're labeling acceleration, you're going to divide not only the numbers, but you'll divide the units that you use to measure them in. So if I measure my velocity in meters per second and my time in seconds, that would mean I would have meter per second divided by second. The way you can write that is you could say meter per second, or meter per second squared. We're going to try an acceleration problem. Just make sure that you have all of this written down into your notebook. In this problem, we have a turtle swimming in a straight line towards the shore has a velocity of 0.5 meters per second. After 4 seconds, its velocity is 0.8 meters per second. What is the turtle's acceleration? To find acceleration, I'm going to have to figure out what is my delta V. So I need to know what delta V is. In order to find delta V, I'm going to have to know what is the final velocity the turtle was going and what is the initial velocity the turtle was going. I'm also going to need to know the time. So I go back and reread my problem. And it says, a turtle swimming in a straight line towards the shore has a velocity of 5.0 meters per second. That is the velocity that we're starting at, or the initial velocity. After 4 seconds, its velocity is now 0.8 meters per second. That's my final velocity. And I also have 4 seconds, which is the time. So, to find delta V, I'm going to take my final velocity, which is 0.80, minus my initial velocity, and my delta V is going to be equal to going to be equal to 0.3 meters per second. Now that I know that, I can take and solve for acceleration by taking my delta V divided by my time. 0.3 meters per second divided by 4 seconds. My acceleration is going to be 0.075 meters per second per second. It is a positive value because my velocity is increasing from 0.5 to 0.8. So every second, my turtle is getting 0.075 meters per second faster. Now that I've explained speed, velocity, and acceleration to you, I want you to do a little practice in your lab notebooks. So you're going to need for this activity your lab notebook. And on the next page of your lab notebook, after the notes you just took, I want you to write task cards on the top. You're going to be looking at some note cards that have some questions for you to answer on them. And there are 13 of them. The other thing you're going to need is there's some multicolored folders at the front of the room. And I think there's like 5 of them, so you'll have to share. Inside the folders, there's 13 questions and 13 answers. So what you're going to do is on the left side of the folder, the note cards in there are going to be the question cards. So you'll pull out the note card. You will read the question on it. You're going to write your answer in your notebook. You'll do that for all 13 of the cards. And you'll get 13 answers. Put the questions back in the folder, because the next class are going to have to use them. Go back in there. And then pull out the answer cards. The answer cards have the letter B on them. So for the answer for number 1, you're going to look for the card that says 1B. Look at what the answer is on the card and see if you got the same answer in your notebook. You can either, what I recommend you do is if you got something different than what the answer card says, get a different color pen and write the right answer in. That way you know either you got it right or you got it wrong, but you want to still know what the right answer was. Once you're done answering all 13 of the questions and finding out the answers, make sure you put your cards back into the folder so that the next class can use them. If you have any extra time today, please use it to get anything from your this week's lab notebook finished. So if you didn't get day 1 stuff done, if you didn't get your lab stuff done because you were absent yesterday or you just didn't have time to finish it, work on getting all that stuff for your lab done. On Monday, we are going to have the quiz on velocity and acceleration. and then we'll start our new week 2 stuff on Monday. So plan on having that quiz on Monday and having your notebooks completed by Monday when you come to class. Have a great rest of your day, everybody, and I will see you soon.